electromotive force and terminal voltage. We have seen how flow of the electric charge gives rise to the electric current. Some force has to act on the particle to enable it to perform motion, or in other words, energy has to be supplied to the charged particle. The device which does the above job is called the source of electromotive force, that is EMF. There are many ways in which force can be exerted on the charge. For example, the force exerted on the charge in an electric cell due to the chemical processes. The force exerted on the charge due to the changing magnetic field. All the above mentioned examples are sources of EMF. A battery, electric cell, is also a source of EMF. What does EMF mean? We shall take the example of an electric cell in order to understand EMF. Let us consider the outline of a battery. There are positive and negative electric charges present in the material of the battery. Chemical processes take place in a battery which result in the chemical force or the non-electrical force Fn acting on the electric charges, which forces the positive charges to move towards the positive pole and the negative charges to move towards the negative pole, where it gets accumulated. The accumulation of the electric charges at the poles produces electric potential difference between them, which keeps on increasing gradually. This results in the electric force Fe, which acts against the non-electrical force. One situation arises in which Fn is equal to Fe, after which no further charges are accumulated at the poles. In this situation, the electric potential difference between the two poles is maximum. This potential difference, PD, is called EMF of the battery. The PD between the two poles is defined as the work done by the non-electrical force in moving a unit positive electric charge from a negative pole towards the positive pole. This work is equal to line integration vector Fn dot vector dl, where line integration is from negative pole up to the positive pole. As per the above definition, the work done is equivalent to the EMF. The unit positive charge gains energy while moving from the negative pole towards the positive pole. The definition of EMF can also be given in a different way. The energy gained by the unit positive charge due to the non-electrical force in moving from the negative pole towards the positive pole is called the EMF of the battery. Its unit is given as joule per coulomb is equal to volt. The word EMF is a misnomer. It is not a force but energy associated with unit electric charge. Let us consider a conducting material between the two poles of the battery. The electric field is thus generated in the conducting material. As a result, positive charges which are at a higher potential will flow towards the negative pole of the battery and constitute an electric current. The question then arises as to why didn't the positive charge move from positive pole to the negative pole of the battery prior to connecting the wire? The reason is that the positive electric charge faces opposition from the non-electrical force. The energy of the positive electric charge is equalized in opposing the resistance of the wire. The energy of the positive charge becomes zero as soon as it reaches the negative pole. During the flow of electric current, the positive electric charge continuously moves towards the positive pole due to the presence of non-electrical force. During the motion, the charges have to overcome the resistance offered by the material which makes up the battery. This resistance is called the internal resistance R. Some of the energy gained by the positive charge due to the work done by the non-electrical force is dissipated as heat in overcoming the internal resistance of the battery. This causes reduction in overall energy in comparison with open circuit condition. Hence, the potential difference between the two poles of battery is slightly lower when the electric current is flowing in comparison with the open circuit condition. The PD between the two poles of the battery during the flow of the current is called the terminal voltage. The relationship between EMF, epsilon, and the terminal voltage, V, can be given as V is equal to epsilon minus IR.